Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. Today we've got our good friend Robert Rogers here with us today from Metla Toledo. And today's topic is foreign material prevention and detection strategies. So welcome, Robert. You've been here many times. You're a firm favorite. Nice to see you again. Welcome.
Nice to see you. How are you doing? Everything's great, I hope.
Yep, super. We've just been talking about the weather. Robert, you're in beautiful
Tampa, Florida, where it's beautiful.
Yeah, and I'm in Manchester in the UK, where actually the sun is shining today. It's a bit chilly, but the sun's shining, spring sunshine. So wherever you're from, you're very welcome. Tell us in the sidebar where you're joining from. Renabeth from the Philippines, Clanette from Greenland. Amazing. Robert from Arkansas. You're all welcome. I'm going to play the sponsors ads now, the video ads. We're back in 2 minutes for the presentation. See you shortly.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food today and tomorrow. AIB International, ever onward.
Okay, we're back. I'm going to give a shout out to Lalit Kumar from India. If you want to pick a couple, Rob, we'll give it a shout out. And there was somebody else from Kelly Miller from Pennsylvania. You're welcome. Okay, get the slides on now. I'll be back for the Q&A later, but for now, I'll hand you over to Rob.
Sounds great. I want to thank everybody for joining me. I'm going to actually go off camera here too, so I don't block anything on the slides. I decided to title this presentation, How Low Can You Go? That's something that I'm often asked when we're dealing with foreign material prevention strategies is how low really do I have to go? And I guess was a good place to start for this kind of discussion. And I really look at it from a couple of different places. I mean, really, who do we have to satisfy? I look at it in three general areas. We have your standard regulatory requirements. These are going to be the requirements that are a requirement based on the territory that the product is being manufactured and or sold in. As an example, here in the United States, of course, products that fall under the FDA are regulated under the Food Safety Modernization Act. In Canada, the Safe Foods for Canadians Act. These, again, are generally regional, territorial. They're generally non-prescriptive. They kind of tell you what they want you to do, but they don't necessarily tell you how to do it. Certainly, these are often requirements, and not abiding by these tend to come with heavy penalties, fines, and oftentimes even jail time for candidates that are nefarious, if you will. Then I look at the third-party programs. These are more the globally accepted programs like you might find under the GFSI or the Global Food Safety Initiative umbrella. These would be like the BRCGS, SQF, IFS, FSSC 22000, and many, many others. Each of these have requirements ensuring products meet regulatory expectations where sold within their standards themselves. So again, not only having to comply with these third-party programs, but also the regulatory requirements, because that will be a requirement of the third-party program. These certifications are typically based on audit-based programs. Often are requirements from branded products if you're a co-manufacturer or a third-party manufacturer of a branded product. These programs might be a little bit more prescriptive. However, there's still going to be many areas that are left open for interpretation and, you know, what somebody believes or interprets the standard to dictate. And then we have maybe even direct customers or intercompany requirements. These tend to be the most prescriptive. They identify how and who should be conducting what activities. And again, so they might be a little bit more prescriptive as to the requirements of size and things like that. But again, none of these standards I might have to comply with all of these standards, and none of them are potentially going to be very prescriptive to the point of identifying exactly what we should be able to detect. If we look at for some guidance, and really I look at it as guidance, and there's some common sizes that we see talked about when somebody asks, well, how small do I have to go? And again, how slow should you go? 7 millimeters, that comes up often. 25 millimeters, both of those specifications, if you will, or guidance, because that's what they are, do come from a guidance document that is 555.425. It's basically a guidance document for adulteration involving hard or sharp objects. In fact, if you look at that document, the board found that foreign objects that were less than 7 millimeters in maximum dimensions rarely cause trauma or serious injury, except potentially in special risk groups such as infants and surgery patients, elderly, those sort of things. And the scientific and clinical literature supports that conclusion. But is that to say that under 7 millimeters is acceptable? Not really. If you look at the Canadian health food guidance, they recommend 2 millimeters. So, you know, do we do 2 millimeters? Do we do 7 millimeters? Is it 25 millimeters in length if it's a non-spherical object? You can see where this confusion comes in. And again, these are just based on guidance documents that are available. If you look at the actual regulation, which is the law, you see words like, if it consists in whole or in part of any filthy or putrid substance, or is otherwise unfit for food. Well, that certainly isn't specifying any particular size. It's certainly specifying that a product that is, or a contamination that is found that is less than 7 millimeters could certainly point to that product being unfit for food still, and cause for regulation and regulatory action on that. regulation. No person shall sell an article of food that has in it any poisonous or harmful substance. A harmful substance could be significantly smaller than, say, 7 millimeters or 25 millimeters, or even potentially 2 millimeters. So where do we get this understanding of what we should be able to do, and how small do we have to go? Again, my direct customers may be very specific for that, but I'm having to abide by regulatory guidance and territories. And as you can see here, there's not a whole lot of clarity in regards to that. I like to adapt the principle that's utilized in radiation emissions for cabinet X-ray systems. Mettler-Toledo happens to provide cabinet X-ray inspection systems, but very similar to the X-ray inspection systems that you would see at an airport. These are all cabinet-style X-ray systems. And as a cabinet-style X-ray system, there's a principle that needs to be followed in the design of those systems to prevent rogue radiation from emitting outside of these devices and causing harm to people who are operating them or working nearby. And that standard is an Alara principle, A-L-A-R-A. And what that stands for is as low as reasonably achievable. We have to control radiation to a particular standard, but even beyond that standard, as low as reasonably achievable. And this is something similar to, I feel, how we should identify foreign material detection capabilities. We should try to protect our products to a level as low as reasonably achievable. Obviously, I can't run a steak or a hamburger through a coffee filter in order to protect it from foreign material and catch any foreign material. It's just not possible. So I have to be able to inspect that product through a device, and that device may have limitations as to what is reasonably achievable. So we certainly have to understand this. Really, foreign material, regardless of size, could render that product adulterated and subject to action based on contamination being proof that that product was manufactured in an unsanitary condition and it's not free of filth or putrid substance. Again, whatever that means. When we look at contamination from that, we also need to understand that where it's coming from. Ideally, inspections are done throughout the entire supply chain, and rather than using end-of-the-line inspection to make sure that that final product is free of contamination. And certainly doing that also puts effort and emphasis towards other initiatives within the business of waste reduction and efficiency improvements. If we're not manufacturing a contaminated product and simply throwing it away at the end, we're removing contamination at a raw material stage, identifying the source, preventing further contamination, and we're not continuing to add value in a product as it goes through there. Of course, there are a lot of technologies that can help with prevention, and prevention really starts from a manner of hopefully eliminating the risk altogether. That's why we don't like wood in the factories, because wood is very difficult to detect once it has been a contamination into the product. So hopefully we can eliminate the source or the risk. If we can't eliminate the source or the risk, then hopefully we can prevent the source or the risk from getting into the product. That could be through means of magnets and sifting and filtering materials. If we can't protect it from getting into the product, then as a final stage, we have to detect when it has gotten into the product. And we can do that through some electronic type controls like metal detection, X-ray inspection systems. And that's kind of what I'm going to focus the remainder of the attention on, as far as giving an understanding of not only capabilities, but also limitations within the systems. So here you have a basic metal detector layout. A metal detector consists of a set of coils that we run a voltage through, and that generates an electromagnetic field. as conductive materials travel through that electromagnetic field, they disturb that field and have a reaction. We simply monitor the reaction of the disturbance of that magnetic field. That is also why a metal detector will only detect conductive materials. It won't detect glass. It won't detect stone. It won't detect bone because of the way it functions. So having an understanding of how the system functions will help you have an understanding of what is reasonably achievable. Of course, there's going to be things that affect the performance of the detector. Listed here, excuse me, listed here we have the metal type. You have typically ferrous, non-ferrous, and stainless steel. Ferrous is more conductive than stainless steel, and therefore it's typically easier to detect than stainless steel. Packaging materials can also have an effect. Certainly packaging materials that have a conductive nature to them. Sometimes during holiday seasons, the packaging department, to have a nice flashy package on the shelf, may want a nice foil embossment on the label to highlight the holiday. Well, that foil embossment on that package is conductive and would start to affect the capabilities and the detection levels of the metal detector. Process activities, process speed, product characteristics, product handling. If the product is consistently flowing through the detector, sensitivities can be achieved that are much more significant. If product is randomly flowing through the detector in several different orientations and in several different amount of products going through there, that can have an effect. Where detections occur within the space of the opening of the detector is important to understand as well. And then you see something there that says orientation effect. How materials travel through the detector can even have an effect on detection capability. Looking at that a little bit deeper, here you can see different orientation effects on a detector. Ferrous will have a different orientation effect than non-ferrous and stainless steel. And this is where it comes into play really when we're looking at not only the ability to detect materials during production, but also have an understanding of re-inspections. I see many applications where metal detector systems identify a product that has a contamination in them. But because the way the system is set up may be too sensitive, where slight variations in the product cause false rejection activities, people tend to take the product out of the reject and re-inspect it because they don't believe it to be a truly contaminated product. This orientation effect makes that process very risky. You can imagine having a contamination in the position of position A, and it's ferrous material. It gets detected, the detector rejects it, it puts the product in the reject bin, and everything is wonderful. But because we don't have confidence in it, or because that line has a high level of false rejects because the system has not been set up properly, we don't have confidence, so we're going to re-inspect it back through that detector. But during the re-inspection, that ferrous metal has shifted its position to position B. And now it doesn't get detected through the detector and it passes right through. And we've just reintroduced a contamination onto the line because simply we didn't have confidence in the system. It's very important that we set systems to successfully run production. And again, then challenge them looking at the principle as low as reasonably achievable. I can set every single metal detector on the planet to its maximum sensitivity to get the best performance out of the detector. But the product itself may not be able to run through the detector at maximum sensitivity, resulting in false detects And you can see where that snowballs into major problems, particularly if we don't have a good reinspection process. Talking about things that will affect the detector as far as the product is concerned. Variations in product temperature. More so, these are visible when we have product temperatures that are supposed to be running frozen. And those frozen products are outside of the freezer and begin to thaw prior to running through the detector. If the detector is set up for frozen product and thawing product starts to come through there, the detector will react and identify a conductive change in the product and maybe result in a false reject. Salt and moisture percentages, product format, again, whether it's foil-based or has any foil embossment on the labeling and things of that nature. Product consistency, again, the more product flows through the detector consistently, the tighter we can set the sensitivity levels. The more variation that is allowed within the product in any of these conditions, whether it's temperature, consistency, orientation, product size, or shape, inconsistencies in any of those as normal production, we're going to have to tell the detector to accept those inconsistencies. And how we do that is typically by making the detector less sensitive to contaminations in order to deal with these inconsistencies. So the more consistent the product can be, the more consistent the inspection will be in the end. X-ray inspection, of course, metal detection, there are many, many other things that can affect it. The environmental condition, product variations, the amount of product going through there. Fortunately, X-ray inspection systems don't have quite as much things that affect them, but certainly there are things that we have to understand and keep in mind when we're determining what that sensitivity can be, and hopefully within the scope of what's as low as reasonably achievable. An X-ray system basically consists of a few different components. You have an X-ray generator. This is how we're going to generate the X-ray energy that's going to be focused down across the path of the product. And below the product, or opposite of the generator, is probably better to say, because not all X-ray systems are a top-down as displayed here in this drawing. We do have some X-rays that are multiple generators positioned at different angles, including some from the direct side. So we have a front-facing view and a rear-facing detector, but consists of that X-ray generator generating the X-ray energy, and a detector that's going to detect the X-ray energy, and then some control system that is going to make decisions. That's typically your computer. When a product passes through the X-ray system, an image is created. This image is made up of several different gray pixels, and each pixel, based on its gray tone, whether it's a darker or a lighter gray tone, will be assigned a number, a numeric value. The computer then takes that data, all those numeric values from all of the pixels that make up that image, and it starts to analyze each pixel's numeric value, comparing it with surrounding pixels, and then making a determination based on various algorithms as to whether or not a contamination is present. There are multiple sensitivities, if you will, or multiple algorithm inspections that we have that are going on through the detector at any given time. If a darker image is seen, you can kind of see that here on the screen a little bit. Hopefully you can see what looks like little spheres on those. Those are the sphere test cards. You get an idea of the difference in grayscale, the darker pixels versus the lighter pixels within the product area itself. Contamination detection is going to be based on several different things within an X-ray as well. Obviously, the product thickness, the more thick a product is, the less X-ray energy that's going to be able to penetrate, or the more X-ray energy we're going to have to generate in order to penetrate a thick product. You can kind of think like X-ray beams, very similar to a light beam. If you think of a flashlight shining through a single piece of paper, you're going to be able to see the light through that piece of paper, just like you would be able to see the X-rays through a thin product. Now take several pieces of paper and stack them on top of one another and shine the flashlight through there. The light is going to be much more dim, and less of that light is going to penetrate through the paper. Same thing with the X-rays. Take a thin product and layer them into a box or a case and then shine the X-rays through them. You're going to need more X-ray energy to penetrate through that product. And the more X-ray energy you generate, you could potentially begin to burn through smaller and less dense contaminations. When we talk about what it can detect, it's all about the X-ray absorption, or how much energy the material, the product, the application, how much X-ray energy is going to be absorbed by those things, and how much X-ray energy is going to be remaining that reaches the detector to be analyzed. When you look at different types of contamination, here's a list to give you an idea of what sort of things may be possible to detect and what sort of things may be impossible to detect. Of course, as we improve technologies and we improve on our software algorithms, some of these things in certain applications might be achievable, but it's always based on the application and the trying to achieve, again, as low as reasonably achievable, reasonably being a key word. Wood, big problem. Wood is very hard, but it's not very dense. In fact, things like organic materials like insects, fruit pits, and things of that nature are typically not detectable. Dense materials such as rubber and gasket material, in some applications, again, this material may be detectable, but it's very application specific. In fact, some materials that are difficult to detect, like certain plastics and rubber, are now being developed with impregnated materials to make them more visible through an X-ray application, and historically even through metal detection applications as well. Certainly materials like glass can be detected in an X-ray, but when you speak about glass, there are several different types of glass. That's why you see here on the chart, we have a low mineral glass that is more aligned with ceramic type materials. And then you have a high mineral glass, and this is more typically around glass jars and things of that nature that might be of that sort of material. If you look at the metal materials, very low on that chart, you'll see ferrous, lead, gold, stainless steel. Certainly they have a very high specific density gravity. That material is very dense and therefore relatively easy to detect. However, if you look further up the chart, you will see another metal, aluminum, and that metal, being a very low dense metal on the periodic table of elements, makes it very difficult to detect. In fact, if you look at aluminum on a periodic table of elements, you'll see it sitting right next to silica, which of course is what low mineral glass is made out of, which is why they're so close on this chart. So it all depends on really the material itself, the product and the application, and exactly what we're trying to do and detect in there. Again, this gives you an idea of how the product is broken up as it travels across the detector, how the image is created and broken up into those individual pixels. In fact, this product here, a foil package, would be an ideal package for an X-ray inspection. Certainly more ideal than a metal detector application. This metal foil bag going through a metal detector would be very difficult to look for metal above and beyond. But in an X-ray system, we're simply looking through the package. So the packaging material doesn't have any effect. The other things that don't have too much of an effect on the detector are things like temperature, the salt content of the product, moisture percentage of the product. So some of those variations that I spoke about regarding metal detection that we have to keep in mind in determining what's reasonably achievable, we don't necessarily have to take those considerations into mind for an X-ray application. For X-ray application, that doesn't mean there aren't things we need to keep in mind, however. Again, it's all about the variations in density of a product as opposed to temperature. So here's a couple examples. You can imagine the example that just looks like the regular block, the little gray rectangle up there. That's a block of cheese, very even in its density across the entire block of cheese. Any contamination that happens, whether it's embedded in that block of cheese, sitting on top of that block of cheese, or whatever, is going to cause a spike in the overall recognized density of that product. Clearly, we have the densities created by the product itself that are very homogeneous and even across the entire product. And you can see where the contaminations lie within the product, the spike of density going above and beyond that product portfolio. Very identifiable and easy to determine. Now take that same product, a block of cheese, and shred it and put it in a bag of shredded cheese now. That looks more like the other example, where there are several variations in the density inherent in the product itself that can make it now more challenging to identify contaminations in certain zones within that product portfolio. Obviously, where the contamination is at a high spike, we still see the spike come up above that. But it's when it's in a low dense area of that contamination, that spike may not go above a product portfolio to a point of being able to be detected by the system. So we always have to set systems up, whether it's a metal detector or an X-ray system, to number one, successfully inspect the product. So any acceptable variation in product densities, in product percentages, in product moisture, in acceptable variations that are going to happen in normal production, we must set this inspection system to accept those variations as good normal product, and then challenge the systems to understand what their capabilities are going to be based on setting it up to successfully run the product. Facilities that try to set their systems up to see a particular spec tend to run into high levels of false reject activities and lower confidence in the inspection process itself. The other thing that we have to keep in mind with an X-ray is the position of the contamination with respect to the generator and respect to the detector. Here you can see a contamination that is closest to the generator is creating a shadowing effect, just as a flashlight would if you were to shine something in front of a flashlight. The closer you are to the flashlight, the larger the shadow appears on the wall. The closer I get the material to the wall, the smaller the shadow appears on the wall. So you can imagine the flashlight again being the source of the detector, or I'm sorry, the source of the X-ray, and the detector being the wall in this case. So we have all this inspection stuff going on. The other important stuff is to obviously understand what these devices are telling us and how these devices are operating within the process. And this can be done very much through the data collection aspect. Whether the system is hooked up to a software solution that Mettler Toledo provides, like ProdX as we show here, or other means of collecting this data, even through a simple USB port on the detector to download the detector and then take that to your computer offline. Looking at the information and the data on there provides a lot of understanding as to not only how your process is working, but how the system itself is functioning for you. Ideally, the production manager doesn't want to see a high number of rejects. He would much rather see a high number of products produced and a high number of accepted products going through the system, identifying that everything has been functioning as intended. If there's a lot of reject activity at one of the devices, that means something has gone wrong. Something has gone wrong potentially with the device. Something has gone wrong potentially with the process and the product, but certainly something has gone wrong. Having a software solution allows the persons to have exposure to this information. The quality assurance person may want to ensure that the tests are being conducted on time, that they're being done correctly, that any reject activity during production is having a root cause analysis conducted on that, and hopefully preventive measures implemented to prevent the problem from happening again. Having inspection solutions in your process don't necessarily prevent contamination. I can be at the beginning of the process throwing BBs into the vat. Yes, the detector will detect that there's BBs in the product once it gets to that inspection point, but it's not preventing me from throwing BBs into the vat. The data and reviewing information and doing root cause and preventive implementation not only is a requirement from standards and regulations, but also is really what the intent of these devices are for. So that's all I have for this. You can see our website down there, mt.com. Mettler Toledo is a very diverse organization. These inspection devices are part of the product inspection division within Mettler Toledo. So you'll find information about all of their divisions within Mettler Toledo. But if you go specifically to the product inspection portion of that site, you'll find information particularly to metal detection, X-ray inspection, vision solutions, and inline check weighing solutions. A lot of great information, free downloads. Certainly you can reach out through those channels if there's anything we can do to help. And with that, I think I have left some time for some Q&A.
Fantastic. Thanks, Rob. Okay, let's get rid of the slides. Switch your webcam on. Yeah, I neglected to say at the start, it is recorded today. We will be sending the recording slide certificate by email shortly after the webinar. So don't worry if you missed a bit. Okay, picking up on the questions. Let's scroll down there. So firstly, a question from Gabriella. Would the ambient temperature have an impact on the metal detector bread type?
So you're going to hear a lot with these questions of maybe or kind of. In my world, there's not a whole lot of black and white. Everything's very gray. So ambient temperature is having an effect. Yes. But more so only if that ambient temperature is affecting the temperature of the product itself. Both metal detection and X-ray inspection systems thermally are capable of operating in pretty extreme environments. So it can work in a cold room. It can work in an environment where the ambient temperature is hot. But where we run into ambient temperature concerns would be a great example, like I said, a frozen product application. If I'm running frozen chicken cutlets, and that's the inspection, the ambient temperature in the wintertime might be a little cooler. So product that's sitting outside of the freezer for any period of time is not going to thaw as rapidly. But during the summertime and the ambient temperature being warmer, obviously that product is going to thaw a little faster. So by the time it gets to point of inspection, it may have an effect. So overall, does ambient temperature affect the performance of the detector? No, but ambient temperature could affect the temperature of the product, and variations in product temperature can affect the performance of the detector.
Okay, that's clear. Question from BV Ravikumar. In the transparent LDPE slash HMHD can be detected in X-ray. So in LDPE film, so HM.
Yeah, so it sounds like he's talking about different material types and asking if they can be detected within X-ray. The only thing, I mean, number one, I'm not familiar with all of those types, so it'd be like if they're similar to polyethylene and polypropylene and things of that nature. Those materials, again, typically are not detectable. However, it always depends, right? Not detectable to the level of expectation is probably the best thing to say. Oftentimes the expectation is that's a small sliver of material because something scraped and caused that debris to go in there, or flaking of material. And typically when you're talking plastics and those sort of densities, X-ray capabilities are going to be more cube type materials. I mean, a chunk of a belt falling off as opposed to a piece of that belt getting scraped and that scraping being the contamination. That being said, there are materials out there, different belting manufacturers and different gasket manufacturers and the like, that are manufacturing materials that are more visible within an X-ray machine or a metal detector by impregnating those materials with different doping materials, beryllium and graphite materials to make them more conductive, things of that nature. I always caution people about those sort of things, just simply because you want to be sure that it's not affecting the tensile strength of that material, so it doesn't make that material more brittle and more prone to breaking apart on you. But really, with anything with X-ray, it's always going to be based on the application. And that, one of the great things about Mettler Toledo is we have a very, very wide global footprint with application centers really throughout the world where products can be sent into us. We can run them through our various inspection devices and provide a report back on what the capabilities were for that particular product, that particular application, and to get an idea of whether certain materials may or may not be detectable in certain applications.
Okay, thank you. Question from Navika. Will there be any improvements for fruit stones in cherries in the future? Were there any testing with different packaging material type in which cherries are packed? Familiar with cherries?
Yeah. I mean, really, with both technologies, metal detection, X-ray, our check weighing systems, all of our inspection systems have a high enforcement from physics. Physics play a big role in what I do. Physics are the ways that the different metal types are affected by different orientation. That's physics. Specific gravity values of different materials and how X-rays those are physics type things. So a lot of that we don't have a lot of control over. What we do have control over is the analysis of the data that we're using from the X-ray being generated or from the electromagnetic field being generated. And that's where we're seeing it changes and improvements. So there's dual energy technologies out there now for X-ray where you can actually look at that product rather than in a singular X-ray power. You can look at it in two different ways and then compare them, remove items. And then some of these materials, again, become more visible. We have seen good applications with what they call the dual X-ray type technology for an X-ray in some plastics, more so because changing the way we create the image allows us to analyze that image differently within the X-rays and makes those things stand out within the image more. Not that we're really doing anything to improve X-ray detection capability, right? We're just improving the way that we analyze X-ray signals, and that happens to have, in some cases, improvements in detection capabilities.
Yeah. Okay. Question from Shardine. What is the best contamination detector for a meat processing plant? Beef, pork, sausage, patties, etc.
Yeah. I mean, it's number one. It's probably a combination of things. Number one, great suppliers. So if you're getting a partially manufactured food, or it's not a whole cattle that you're taking through the full process of slaughtering and packaging and everything, if you're getting a material from someone, make sure that they're doing some provisions to protect it, or at least understand what they are or are not doing to protect that product from contamination. Anything that you have in your environment, ideally, again, the goal should be to eliminate the risk and the hazard. If you can identify a risk and a potential hazard and you can get rid of it, get rid of it. So it's not a problem. If you can't get rid of it, then find ways to protect it. Obviously, that product is going to go through different stages as it goes through the value supply chain until it's that final product in the package ready to ship out the door. With a metal detector, the size of the detector will affect it. So if I can inspect the product as a single steak, if you will, through a detector that's this big, it's better than running it through a case of detectors or a case of steaks that I have to have a detector this big, because that's going to be less sensitive overall. I also have to think about the reject. I'm rejecting an entire case of product. Which one of those steaks is the contaminated one? And do I have a process to rework them so I'm not throwing away 20 steaks because there's one that's contaminated? So a lot of things that you have to think in with that. I look at not only the abilities of technology, but the inabilities more so, the limitations of technology in my decision making. So a metal detector, like I said, can't detect bone. If bone is a concern because it's a boneless product, then X-ray is going to be a solution for that. If there's aluminum risks within the process for whatever reason, an X-ray is more challenged to identify aluminum than a metal detector. So a metal detector might be better in that application. It sounds like, hey, Rob Rogers, Mettler Toledo, they provide both solutions. He's telling me to buy both of them. Yes, I am. Whichever one gives you the best protection against the product. And that's why it's more so than just really putting a system in place. Hey, put a metal detector here, put a metal detector there, put an X-ray there, whatever. It's understanding where the best value of having the inspection process is. And sometimes that's even to protect further processing equipment. I want to have a metal detector inspecting a frozen block of product prior to throwing that frozen block of product into a grinder. Because if there's metal in that frozen block and it gets in that grinder, now not only do I have a bunch of contamination because it's all shredded, but now I've broken the grinder and now I got to pay to replace that and fix that. So, it all depends on where in the process we want to put it. And there are ways to understand that. One of the things that I do with the business is I do a safe audit where we do just that. We understand the challenges in the business, where they are, where they want to be. And then we assess the inspection from raw material receipt through final packaging and figure out where the best place to have solutions are that gives us the most impact and the greatest value. And that's what should be the process, as opposed to what technology versus another. Sometimes it's a combination and it's all of them together that prevents it.
Yeah, super. Walter, if I have an X-ray system as a CCP, what parameters can I use to set up my critical control limits?
Yeah, I mean, historically, a lot of our systems are identified as that critical control point or as a preventive control point. And establishing what those parameters are, again, that's kind of going back in number one. Are there any things that you have to achieve? Is your customer or your contract or whatever requiring you to meet a specific requirement? That may dictate, number one, where in the process we can achieve that. Again, a single steak versus 10 steaks, or if we have to have multiple inspections throughout the process, because I can control it to that level here, I can't control it here in the 10 stack case, but I can do a risk assessment from the 10 stack case to where I was able to achieve it down to that level. And if the risk is underneath my critical limit, then okay, I've controlled the hazard. But how do you determine what that is? It's really a matter of, again, I look at it from validation as a key critical component to understand what is possible in a production environment. And that's going to be in the system to identify what affect it, how sensitive, what is reasonably achievable. I can set the detectors super sensitive to detect the smallest contamination, but if 80% of the product gets falsely rejected and we have to rework it, there's no confidence in the inspection program, and therefore, it's not working. It's failed. So it's really a matter of ensuring that we have a good working system that's within factory acceptance parameters and functioning, that it's installed properly, and we understand any adverse effects from the installation and control them as best as we can, set it up to successfully run production so that all the variations that we accept as good quality product, the systems accept as good quality product, and then challenge the systems in their weakest area to identify what is possible. And that would be a series of, 30, 40, 60, 100 passes, whatever you choose to do. But that's how you would establish what that critical limit will be for you successfully. Now, some people just say, well, the customer says I have to hit this, so that's what I have to hit. And, well, sometimes good luck.
Yeah. Okay. Yeah, Miara, yes. I'm sure we can put Robert's contact details in. You don't mind, do you, Rob? If someone wants
No,
to
not at all.
Also, Gertage. I've been using MT Xray for the past 6 years and been very impressed with the equipment and service. It's a great tool for food safety. Okay, that's nice. Renabeth, question. Can you provide an X-ray machine which is not dependent on the density of the contaminant being detected? That'd be nice.
Yeah, there's a lot of things that I want to do. And if I was able to do them, I probably wouldn't be here talking with you all. I would be a very rich man sitting on my yacht. Yeah, I mean, again, there's a lot of limitations that we have that are just physics-based that we're not going to be able to change. There's going to be improvements, again, in some of the algorithms and some of the speeds and in some of that. We're starting to see some introductions of other technologies for foreign material inspection, very similar to MRI type technology that we see in the medical field. The problem with those sort of technologies and that sort of advancement, those next step changes in technology, like X-ray was for metal detection, those things are a little bit slow to be, number one, accepted, proven in our industry, and they tend to be very, very high priced as a point of entry into the market. So they're very, very slow entry from that point perspective as well. And it just takes a long time. I think eventually we will see those technologies in there because, quite frankly, current technologies are limited. Those technologies would be limited just the same. In the first part of the slide, I gave you some idea as to the confusion within even standards and regulations and, okay, what should we get? How should we get? That's why I like the Alara principle, because through validation, that's something that you can prove. This is as low as reasonably achievable for my application where I'm running the 12 stakes through there. Another application, they're not. They're running the 1 stake through there. They can go through validation and they can prove that was as low as reasonably achievable for them. But standards, again, aren't generally that prescriptive and whatnot. So there's all this confusion that's left out there for everybody else to deal with. And the fact of the matter is we have what we have today, right? Foreign material is not the number one cause of recalls. Typically, it's labels and allergens and microbiological type contamination. It's not physical contamination, but physical contamination is always the number one consumer complaint. I'm going to eat my sandwich. I might feel ill. I'm going to feel better. I'm not going to complain about it. I'm just going to say, I ate that sandwich. I fell ill. That's the end of it. I bite into that same sandwich and then there's a bolt in there or a screw in there. I'm going to start raising some cane about, hey, what's going on here? Why am I biting into this piece of glass or this screw or this whatever? So it's the number one customer complaint, and it typically affects the largest amount of products. But for me, it's the one problem in our industry that's solvable. I'm never going to solve microbiological contamination, but I can put a really, really good dent in understanding how to control foreign material within my facility based on principles like the Alara principle. And it's validation capable and provable. So yeah. I think it works.
Excellent. Lalit Kumar, if products itself contains an amount of iron, is there any solution for the detection of contamination?
Yep. Again, I mean, product effect is what that is. Products that have higher iron content in them have a conductive nature to them. Iron is a conductive material. Magnetic fields are affected by conductive materials. So those sort of products, if the product conditions limit a particular technology, I may look towards other technologies to satisfy my need. So in that case, if I had a product higher in iron, I wasn't getting satisfactory as results from metal detection capabilities, I would look into X-ray capabilities and see if there was a significant difference in capability and improvement in capability. And if there were, you may also recognize other advantages, because obviously not only is it going to run the iron product better and detect a better metal spec, but it may also be able to detect some plastics and glass and stone and other contaminations that may make their way into that particular product. But as I said, the best thing to do in a product inspection field is partner with a group like Mettler Toledo, build a relationship, send products into their many application centers around the world, test and challenge the systems and get a report back on what those capabilities are. And if they're in the right direction, then dive deeper into those conversations and explore them further.
Okay, great. What would cause false rejects in cheese? And that's from Gertech.
Yeah, I mean, cheese, again, kind of depending on things like temperature and moisture percentage and salt content can be in effect. Position where we inspect it. There's some applications in cheese where they're going through a salt brine type bath for a long time. And, some people I've seen inspect it right after that, and that brine and that salt being conductive and certainly being more moisture and at least on the surface area, even of a block of cheese at that point, let alone versus a dry aged cheese. That dry aged cheese is going to be less conductive. But again, cheese likes to tend to have fancy foil packaging material for preservation of the cheese and for presentation on the shelves. That point in the inspection may be more challenging to a metal detector applications. The answer to get rid of false rejects is to set the systems to successfully inspect the product. And we do that through validation. If there are variations in temperature that are causing the problem during a setup of the inspection device, have those variations in temperature available during the setup and have the system accept those variations. That will eliminate that variation as being a cause of the false detect. Understanding that, though, again, typically as we reduce sensitivities, it's also reducing the sensitivities towards the detection point. And that's that fine line between what is reasonably achievable and then what maybe we're trying to do to meet a mandate or anything like that. If there's a spec, I appreciate these things. We have to achieve these things in order to be able to sell our product to this particular group. I appreciate that. That doesn't necessarily mean that there's no way forward and no way to do it. It just means that maybe the position that it's at today isn't the right one. Again, maybe there's a point earlier on in the process where we can have a smaller detector or a more consistent product, where we have less likelihood of variation, so less likelihood of a false reject, inspected at that point and determine from that point to final packaging where the product is fully protected, what are our risks in that space, and can this detector handle those risks? Most likely it's not going to be the smaller contamination because it's, further down in the processing where less of that activity happens. So there's no real good answer for it other than to say, hey, to get rid of false rejects, you set it to successfully run production. And if you're getting false rejects, it's not set to successfully run production, or production is not controlled to the point that you're expecting it to be, and the variations are falling outside of the capability.
Yeah, makes sense. Ravina, is there any technique to identify the nature of foreign bodies, for example, to differentiate between metallic particles?
Yeah, so that's where the real challenge comes in. Some people say, hey, it's hard to do metal detection, it's hard to do X-ray, it's hard to do these things. No. The real challenge is in that question right there. How do we determine what this material is now that the detector reacted and rejected something? And where did it come from? And how do we determine that? There's no real way that the inspection system does that for you. Really, the detectors and the inspection devices in that sense are somewhat unintelligent. All they're looking for is the contamination. They don't care what it is, why it is. It's just something different. And so, boom, I'm going to react to it. There are laboratories out there that do different analysis of materials, especially around metals and things like that, to determine exactly what the material type is. Even once you identify that, the story's not over. Okay, well, where did it come from? And do we have any of this within our facility and anything like that? Yeah, that's what makes these things very, very challenging, is that root cause analysis, which is why I'm such a huge advocate of inspections throughout the process, including at the raw material stage from your raw material suppliers. If I inspect that final package of cheese before it's going on the grocery store shelf or into, Rob Rogers's refrigerator, if I find a contamination at that point, well, where did the contamination came from? Well, it could have come from the grocery store. It could have come from the delivery truck. It could have come from my ship shopper that brought it to my door. It could have come from the manufacturer. It could have come from the milk producer. It could have come from the whey, so there's going back throughout the entire supply chain to try to figure out where this came from is almost impossible. But if I'm inspecting at this stage in the process, if I'm ensuring that my raw material suppliers are protecting the product to this level, then I can kind of, I don't have to look as far back in that value chain to understand where things went wrong. In fact, that's all the inspection devices do for you, really, is they identify when all your other things that you put in place to protect it from contamination failed. Your maintenance program failed because your equipment's breaking down and creating contamination. Your raw supplier, agreement failed because your whey or your milk producer provided you with contaminated product. Whatever the case may be, it's just an indication that all the things you did to prevent contamination have really failed because the thing went beep and it found contamination. So it's only part of the process for sure.
Okay, question from Bernard. Can the customer change by himself the ampere, mass, or kV, e.g. to retest after in the evening?
In some cases, yes. I mean, there are adjustments certainly with the kV is and the amperage is typically talking with the the X-ray application where we're changing the power levels and the penetration levels of the X-ray system. The MA, the milliamps control, the current control, typically tends to affect the resolution of the image. So obviously, people are familiar somewhat with resolution as our computer screens and everything, and our phones even are getting better resolution, and all the screens are beautiful. But back in the day, we can think of when you watch footage from the astronauts landing on the moon, all that footage is super grainy and the resolution isn't very clear. Now, put that in the perspective of X-ray inspection, where that's all we're doing is analyzing this image, a much clearer image with a lot of resolution. There's going to be a lot of definition in things, and I'm going to be able to observe a lot of things versus looking at the landing on the moon. Everything's graining. It's hard to tell what the resolution looks like. It's hard to pick out definition. Some of those values within the KA and or KV and MA on an X-ray system are adjustable, but they're usually adjustable through the auto setup feature when you're setting up a new product. In the background, as we're setting up a new product and learning that product image, those are automatically being adjusted to optimize the setup of the performance of the detector. Once that's been optimized through those auto setups, is a good idea to go in there and tweak those things. And what do you get out of tweaking those things? I'm not a big fan of tweaking things. Again, I think if we're tweaking things, then we're not working within that what is reasonably achievable space. We're starting to get outside of reasoning when we're starting to do things to tweak it. So yes, in some cases, those are adjustable, but typically they're on the backside, and adjusting them outside of what the system determines is the best might not provide you an advantage. In fact, it might cause more problems than it provides benefit.
Yeah. Okay. I've just counted the questions that we've left to answer. 36. You probably answered about a dozen or something like 15. See, what I don't get is that you provide a good presentation and your answers are really practical. That's real getting to the nitty gritty of it. But it shows you what a complex and problematic process that people find it, don't they? Yeah. Really.
Yeah. And I really blame, the regulators, because, they should provide more guidance or give us a baseline of what to do. That at least gets us a limit and a target to go after. I think, again, 2 millimeters isn't the answer. It should be smaller than that. It should be 0, right? It should be no contamination. But that technology isn't there to do that. Again, I can't run a steak through a coffee filter to get rid of that bone contamination. If I did that, it's just mush coming out of the coffee filter and not a very tasty and appealing steak anymore, right? So we have to live within the space of the realm of what is possible. And that's going to be a moving target as well. Again, as we improve on the software and as we improve on technologies and we adapt new technologies and new methodologies to do things. It makes it an interesting field that we're in, Yeah, it's super important because our food supply absolutely must be safe and of good quality. No doubt about it. So it's super important, but it's not an easy task. And sometimes it's a matter of taking step backs and taking it very purposefully and systematically, kind of like I've described to answer some of these questions, hopefully.
Yeah, well, we'll take a few more. We can't answer; it's impossible to answer more, but we'll see how we do. Renabeth, we are currently using Mesotoledo X-ray machine in canned products. Why is it that the pull tab of the can is not detected, but the lid is being detected?
Again, it's kind of very specific application stuff. There could be a lot of reasonings to that. It could be a setup issue. Obviously with the tab of the can, that's going to be an area within the can that has a difference in density versus the surrounded area. And as I mentioned, that's how the algorithms work. They're looking at the individual pixel values within that image and doing comparisons with the surrounding pixels. So edges of that tab might be causing enough of a difference because the tab, obviously, it's got to have some flat edges and it's probably going to have a rolled edge on it. That rolled edge is going to be denser. and there may be differences enough within there. Oftentimes with the Xray system, there should be, and again, I'm not 100% sure whether it's only available in the setup screen or whether it might be available as long as you're logged into the proper level to do it. But there should be like an update button. So if you're doing a setup and it's tagging on something as a contamination that is in fact a piece that should be accepted within the product, you hit basically update and it accepts that parameter and readjusts those parameters. Again, keep in mind, every time we do that sort of stuff, typically adjusting parameters is desensitizing the device, making it less sensitive towards these changes. That is going to affect the overall detection capability as far as a real world contamination is concerned. And again, that's the fine balance that we have to walk through as far as what's acceptable. And we want to detect as small as possible, but we also want to be able to successfully run productions and understand what the system is capable of truly.
Yeah. Prasad, can we detect glass pieces in liquid products by any detection process?
Yep, we do several applications where we're running a glass-in-glass inspection, which is probably one of the most challenging inspections that we do, because typically you're going to have a glass bottle, and as that cap gets put on that glass bottle, maybe a chip breaks off and falls into so now that's a piece of contamination inside of the same material that contamination is made up of. And now you're trying to identify that. That's one of our most challenging applications. But again, can be done and is typically done from, I'd spoke in the presentation about the Xray source and having not just a top-down inspection point of view, also sometimes a side point of view, and then different angle points of view. The more points of view I have, or the more images I get to analyze through the computer, the more likelihood and detailed inspections I'm going to have of that product, whatever it may be. So yes, glass pieces in liquid applications in that sense, from a package perspective, certainly possible. The other liquid applications that we do in Xray would be a liquid flowing product. So it's in a pipeline application and the product flows through the Xray system, and we're looking for contamination just in the raw liquid material as it flows through the pipe. That is also a possibility, and certainly with Xray inspection, glass contamination in that application would be detected, capable.
Okay. Question from Nancy. For a tunnel metal detector, how can we eliminate vibration and electrical noise that cause false detection?
Yeah, so a couple of things there. A metal detector, again, as I spoke of, metal detectors have a little bit more sensitivity towards the environment and the outside influence and the system and how they're installed and things like that. So vibrations is one of those characteristics that make it challenging for a metal detection. Ideally, the system isn't affected by vibration. So a couple of different things here. I look at two different areas. I look at the system and the installation as one entity in and of itself. So I want to make sure that I have a good system, and a good system is stable to vibration, so it's not affected by vibration. The installation is good and sound and not affecting the system, and a good installation won't be affected by vibration, even at maximum sensitivity of the detector. Once I have an understanding that those are good, I have a good system, the installation is good, and really vibration isn't a problem for me. Now we have the results when we bring product into the equation. And like I said, moisture percentage, temperature, conductive nature. The product itself might have some characteristics that I have to tune out or ignore from the detector in order to set the detector up to successfully run the product. Okay, so I do that, blah, 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 change some things. Well, those changing of some of those values may make the detector more susceptible now to the vibration. So again, I need to understand that, is it a problem with vibration due to an installation, or a detector problem? Or is the vibration inherently an issue due to the product settings required to inspect the product? And if it's required to inspect the product, well, then again, I may just have to desensitize it, which is going to affect what I'm able to detect, in order to have that successfully set up to inspect the product, not necessarily set up to achieve a metal result. It's a kind of a fine line, and sometimes even a choice that we might have to make. Do I deal with excessive false rejects because I'm able to achieve what I want to achieve? Or do I risk not being able, or maybe having to adjust what's acceptable of what I'm able to achieve, and able to have 100% of my good quality product 100% pass through and be inspected successfully in the inspection device?
Okay, Maria, could you explain if metal detector is calibrated by the supplier or just it receives a maintenance service to adjust parameters? I know you don't like the word calibration, do you?
Yeah, not a huge fan of that term, particularly when it talks to metal detection, but I understand where they're coming from and what the topic talks to. Again, calibration in this sense is ensuring that metal detector, all of the internal tuning and balancing and electronic signals that we evaluate to say, hey, the electromagnetic field is strong enough. It's on the right phase angle, the right pitch. It's not having interference of electrical internal noise and things like that. Those are the tuning functions of the device itself. And those sort of things are things that I would recommend are done by the original equipment manufacturer. Those sort of services today, under the term calibration, may not be conducted to the level of getting down to those diagnostics. It's kind of the same between sending my car for an oil change, right? I can do an oil change myself, but all I can do is change the oil and replace it with new oil. I'm not necessarily going through the diagnostics and making sure the brake pads have enough padding still on them, and there's no error codes through the diagnostics and the electronics and stuff like that. It's the same thing. I changed the oil. That was the function. But when I take it to the dealer to do that, he's doing much deeper diagnostics. He's getting into the things that may even only be visible to him as a manufacturer, with tolerance levels based on, we changed that tolerance level because we looked and we could tighten it up and better perform. So things like calibration services, when we talk about those things, if it's calibration under those terms, I think an original manufacturer is the best person to perform those services for you. If it's just simply coming in there and saying, hey, does it detect X, Y, and Z, and did the reject device operate? Very similar to the activity that's conducted through their daily operations when they're doing their daily performance verification activity on the system. Well, yeah, you can do those activities. You're not doing anything different. But be very cautious as to what those services entail and exactly what you get out of it. Because I look at that annual service to make sure that device is working correctly, is that annual service, making sure my car is functioning so that when I go on this long trip this year, it's not going to break down in the middle of the road. That's more than just changing the oil, if you kind of get the analogy.
Yeah, sure. Last question. Bernard Terrier, can you detect insects with Xray?
Yeah, typically organic type materials like insects, like wood, like hair, like fingernails are not detectable in an X-ray application. Organic materials, including us as humans, we're largely made up of water. And water is what a lot of products are made up. I mean, if you look at lettuce is probably 90 some odd % water. And several food products like that were water-based things. If you think back to that chart I showed of what was detectable and what wasn't detectable, water gives us a specific gravity of 1. That's our baseline. Anything that's less than 1, no chance of detecting. It has to be greater than 1 in order to be detected. In fact, we often use water as a reference. If you drop something into a glass of water and it sinks very rapidly to the bottom of that jar, you have a good chance of detecting it because that means it's dense, and it's certainly more dense than water, which is why it rapidly sank. But if you drop that into a glass of water and it just sits there and floats, you have nearly no chance of seeing that. So things like human hair, it's going to float. An insect, it's going to float. A toothpick, it's going to float. Those sort of things really aren't very well detected in X-ray. Now, again, that being said, with some of the algorithms and software changes that we're having advances in and speed of processing powers and things like that, may make some of those more visible in certain applications. A mouse is organic. If I had a mouse in a bag of or in a powdery macaroni and cheese powder pack, I would see the mouse in contrast with the powder pack. But if I'm looking for a mouse inside of a bag of chicken nuggets, now it might be more hidden because the densities are different and things like that. So, I don't want to give the answer a broad no. Testing would result in that, and chances are on the lower end of that being a potential.
Okay, we'll have to leave it there because we're 22 minutes past the hour. We're way over, always. Yeah,
well, there's still 260 people in here, and I thank you all for sticking around, and I hope this has been helpful. I appreciate it.
It definitely has. It always is. And like I say, no matter if we was here for 3 hours, we'd be still answering questions, which, just despite how good your replies are and your answers are. So, yeah, it's always great fun. I think we'll have to arrange another ad hoc one just to come on and answer questions again, because it's the fun part. So we might do that. So watch this space. But in the meantime, thanks very much for your time and sharing.
Can I put something in the chat just so everybody's in there? I'll throw my email in there. I don't.
Sure.
Yeah. It's pretty simple. It's robert.rogers@mt.com. I think I can type it in there.
Yeah. What we'll do is in the follow-up email, I'll include your contact details, but I'll also link to the, the guy. You've got some good guidance documents, haven't you, on the Metal? So I'll put a link to the resources page of Metal Toledo. I'll put Rob's email in there, and you can catch up. And then, like I say, we'll have to organise something else in the near future. But for now,
always good.
Cheers, Rob. I appreciate it.
Appreciate you.
Thank you.
Take care.
Brilliant. I've loaded your certificate in the sidebar, everybody. If you click to download that, you can print and sign or open it in an image editing software and type your name. Thanks very much for your attendance. Thanks for your engagement. It's super every time. And we'll see you on the next one. Happy Friday. Enjoy your weekend. Take care, everyone. Bye.